All right. Hi, everyone. Welcome to our first English talk of the day. So welcoming Tyler, who's going to talk about using open source data from the MITRE ATT&CK framework to better understand your closed source EDR software. So I'm just letting you go on this, and have a good afternoon, everyone.
All right, thank you, Patrick. So everybody, I'm Tyler Fisher, and I work at Great West Life on our red team. So I pretty much play around on my day-to-day with a bunch of open source data sets. For example, I play with the Atomic Red Team framework quite a bit, as well as MITRE ATT&CK framework, MITRE ATT&CK Evaluations, the Navigator, as well as other frameworks such as CAPEC, CWE, and CAR from the MITRE ATT&CK Analytics project. For the most part, these allow us to kind of figure out what exactly, for one thing, EDR solutions can actually see at the end of the day. So what can Windows Defender ETP see versus FireAHX? At the same time as well, though, too, what can we figure out about adversary tactics at a very granular level? Let's say we have TTPs tied to, example, a threat group. Maybe it's FIN7 or it could be APT28. We should go to very granular and figure out exactly how these techniques exploited in the wild, as well as what trick graph they use to exploit them as well, what kind of software they use, as well as mitigations you can apply to those different techniques. I work quite a bit on things like developing agents, microservices, tooling, and web apps to support the red team, and also build infrastructure for us to use to simulate these actors. So a lot of it involves forming local and distributed control testing with the Atomic Red Team framework, but also MITRE ATT&CK. We can actually use MITRE ATT&CK Evaluations framework as well, too, to kind of give us a baseline understanding of what's observable, as well as what is still an unknown to be tested through black box testing. The biggest value out here is that we can use MITRE ATT&CK framework to figure out what TTPs we can see from these different vendors versus just what's in the marketing materials. Actually prove out what is detectable. So we're going to talk about a bunch of things today. We're going to talk about, first of all, how you can use open source data from MITRE ATT&CK to better understand what you actually see with your EDR software. For example, let's say you're using Microsoft Defender ATP, you might be using Carbon Black or FireAHX. Also going to talk about how MITRE is using Caldera to figure out which TTPs are discoverable by different EDR solutions. We're going to use TTPs tied to APT3 as well as APT29 as a basis for our research here. Let's figure out exactly how TTP articulate the analyst in the SOC whenever an alert is raised. For example, let's say that you have an analyst looking at use of mimikatz in the wild, performing both credential theft and lateral movement. You can see with the evaluations framework what exactly they're going to see, as well as what is grouped all together in a single alert package. Also going to look a little bit at how to translate these evaluations into Navigator layers, so how to visualize them and show the actual baseline level of coverage. We're going to use ATP as an example. There is currently 21 vendors participating in this framework. So you can actually look at results from vendors such as Carbon Black, FireEye, CrowdStrike Falcon, and many more. So at the end of the evaluations framework, it allows you to study what is seen with EDR solutions and how do you do it in the first place? It's going to be through a MSSP, it's going to be through an IOC list, or even just general behavior through different correlation rules. So in 2018, we had 11 vendors participating in the evaluations for APT3, and they used Cobalt Strike as well as PowerShell Empire to emulate the behavior of this actor. You can see down in the bottom of the screen, we have all the TTPs that were in scope for the evaluation, and breakdown on a per tactic basis. And the following year, there were 21 vendors participating, and they used Puppy, Interpreter, and POST2 to emulate APT29. If you combine these two data sets together, we can actually figure out on a per vendor basis what is detectable in theory as of 2018, as well as what is detectable now, and see the actual change in coverage over time across multiple vendors. So in this example, here is what we have from Microsoft. So you can see here what the actual techniques that were tested were, as well as a breakdown of what alerts were tied to those techniques. You can see that they had a breakdown, a lot of them were from the MSSP arm of Microsoft, as well as some were through telemetry. Also see as well like how they configured ATP during the evaluation itself. You can see that they used Defender ATP for Windows Server 2019, as well as for Windows 10 was the actual endpoint system they used. And then on a per technique base, you can see exactly what was identified during the evaluation. So let's say there was a procedure at the top where a user executed a malicious payload called rcs.doc. You see that it spawned a process for Explorer.exe, and that forms user execution technique from the MITRE ATT&CK framework. You can also see exactly what they would see if it was tripped in the SOC itself. So here's more details on the results tied to credential dumping. We're going to go take a quick look at what the analyst would see as well too in their console. So you can see here the process tree tied to execution of mimikatz. So see that it started partial process and then it's executed. Do that. Here's the that's raised to the console. You can see that came from EDR aspect of Defender ATP rather than the AV aspect of it. So the process command line, that's right side of the screen, as well as the checksums of that process, as well as any related alerts to in the alert package. So today you want to figure out essentially how we can actually go from these data sets provided by MITRE to actionable insights into what's detectable by these solutions. So here's a kind of high-level overview of what we can do to do that as an example. So first off, you want to figure out what TTPs you actually care about. Let's say you want to look at all of the TTPs used by Fin7 for things like executing malicious code, getting persistence, and also forming credential theft with tools like Mimikatz or Losange or whatever it's going to be. And from there, I figure out what TTPs were in scope or out of scope for given evaluation. Let's say you want to compare these TTPs to what we studied with APT3 and APT29. And then you want to subtract those TTPs that are going to be out of scope. But then next step is going to be to highlight any detected TTPs, what weren't detected, and they weren't actually tested at all in context of the evaluation. You can actually look at some of the results too for Defender ATP in 2018 as well as 2019 now, and see what's actually the baseline for these detections. So here is the results from the APT3 evaluation round. So you can see we studied data from all these different MITRE ATT&CK tactics. Particularly if you look at defensive agent techniques, you can see that everything was detected is going to be in green. If it's in orange, there was no detection demonstrated. And gray, it was just not tested at all in this case. You can see, for example, we tested out things like dumping credentials. We tested out capturing user input, the use of run DLL for code execution, and schedule tasks, for approach escalation. Now here's the following results from the next year. So you can see where they improved actually over time. So after the next evaluation, you see there's quite a bit of reduction in what was actually not detected, and also what was actually in scope between these 2 years. This kind of shows you exactly what is a baseline level of coverage for ATP as an example. You also have the ability to compare multiple vendors' products to figure out what's detected most often, as well as where the common coverage gaps are among the multiple vendors. It'll be a next step, though, for sure, for this kind of stuff. But yeah, that's it, actually, Patrick. Kind of breeze through that, actually.
Awesome. I'll get some question from the YouTube. Anyone have some, please write it down, and we'll go through it. And we'll wait a little bit for that. All right. I know Tyler is also on the Slack of AgFest. If you want to ask question later, that'll be possible. I think you're even doing a CTF tonight, right?
I am, yes.
Awesome. So I'll post his nickname. Well, I think it's your name directly on the Slack. And for any question, you can go from there. I'll post also the URL for the YouTube videos of the next talk, which should start in 20 minutes or so. Oh, one question that comes up. What's the measuring scope?
In this case, all the scope's kind of defined by MITRE, actually. So it's actually defined on their website. So they tested out these techniques across all these different tactics. So in this case, for ATP, they tested out everything that's highlighted in this Attack Navigator view here. So you can see for execution, for example, they tested out about a dozen techniques. Everything that's on the screen here is actually going to be in scope, the evaluation for APT29. And then APT3 is a bit different. Here's the actual scope for that one. It's slightly reduced. You can still see what is actually going to be tested out here. So the methodology as well too on MITRE's website, because it gives you a play-by-play of how they should do the evaluation, what scenarios are in place, as well as what they did at each step of the evaluation. So how they actually tested out for credential access, how they tested out capturing user input, and so on and so forth.
What's the color exactly represent, just to make sure for everyone?
So in this case, green is going to be detected, orange was not detected, and gray was untested.